Only two types of questions appears from Beckmann rearrangement. One is an aliphatic, alicyclic one. Another one is a cyclic one. So let us understand it here. I have RRC double bond NOH. This is nothing but oxime. We just now saw the synthesis of oxime. When I am having a carbonyl, when I treat it with an hydroxylamine, what you form is an oxime, C double bond NOH. How do I identify it as Beckmann rearrangement? Usually they will provide you oxime in the presence of H+. Usually the H+ is sulfuric acid or HCl. It reacts with H+ here. Let us look at the mechanism. The oxygen's lone pair reacts with the H+ here so that it becomes O plus H2. Now this R migrates to this N and this O plus H2 leaves as water. Now what do I have? R, this R, C, because this R dash went along with its bond pair, the carbon carries a positive charge. Double bond N R dash. Now it is reacting with water. So this oxygen lone pair attacks this carbonyl. Oxygen gets a positive charge. In order to have its lone pair, this moves out as H+. So that I form RCOH double bond NR dash. You can see it is very similar to your keto-enol tautomerism, isn't it? So where this can move on, this can take the minus charge. So I form RC double bond O, N minus R dash. This H+ will attack it to form an amide. So what you are creating here? You are creating oxime in the presence of H+ to form N substituted amide. Clear, da?
Yes, ma'am.
Right. So how do I identify this Beckmann rearrangement? You will be provided oxime. Sometimes they start even from an aldehyde. They reacted with hydroxylamine. They form oxime. From there it goes on. So oxime in the presence of an acid will provide you N substituted amide. Let us consider this example here. The group that is in anti-position to OH group is migrating. I am having OH here. Anti is opposite to it. CH3 is here, right? So the group that is in anti-position to OH is migrating. So what would happen here? The one which is migrating will be next to the nitrogen. That's it, isn't it? So I'll have C6H5, CO, NHCH3. Clear, pa?
Yes, ma'am.
Right. Now we will see the formation of caprolactam. The cyclic one, I told you they will be providing you this alicyclic as well as cyclic one. We will see this caprolactam. Look at this here. I am having the cyclic ketone here. It is reacting with hydroxylamine. The moment it reacts with hydroxylamine, it should have formed oxime, isn't it? So it will form oxime. Look at the next step. H+ in the presence of heat. Let's understand the mechanism here. I am having ketone here. NH2OH reacted with it. You need not look for the complete mechanism because we are not for the mechanisms here. We are not doing any graduate degree. So I am directly hitting at this final product. Ketone, when it reacted with NH2OH, remove the H2O and you will form oxime. Clear till this step. C double bond O to C double bond NOH. Clear till this step?
Yes, ma'am.
Yes,
Right. Now once it is becoming C double, I am giving you an H+ here. An acid is attacking. So once the acid attacks, it forms plus OH2. It moves out. Once it moves out, what would happen? As I told you, one of the R groups should migrate to N, isn't it? Look at this. The cyclic ring is here. This is look at the bond 1 and 2. I am breaking the bond between 1 and 2. Instead, I am making the bond between 2 and nitrogen. Can you see that? I broke the bond between 1 and 2 and I make the bond between 2 and nitrogen. So right now I made the bond with 2 and nitrogen. What about the first carbon? It lost its bond. So wouldn't it carry a positive charge? Yes or no?
Can you repeat that one?
See, in your alicyclic compound, you just migrated one of the methyl group to this nitrogen. You created the positive charge on the carbon. I'll show you for one more time if you want to know it again. Look at this. The CH3 is migrating to nitrogen. Look at this. We migrated this R to nitrogen so that the water left out the group, correct? So that you created a positive charge on the carbon. Which carbon?
Yes, ma'am.
The carbon that was double bonded with nitrogen. Then only water attacked. It is an alicyclic compound, but here it is a cyclic compound. That's the only difference. Whatever is the case, you create a carbon which is double bonded with nitrogen that carries a positive charge. That's it. To that the OH will attack, then you do a keto-enol tautomerism, you form a ketonic part there. Understood, Ra?
Yes, ma'am.
Yes. We are doing the same thing now. Look at the cyclic compound here. Look at this step. Are you creating a positive charge on that carbon?
Yes, ma'am.
Yeah. Now the water is attacking. Then what will happen? It will form OH. Correct? C double bond NOH. Now you will do a keto-enol tautomerism there. So it becomes double bond O. Do you understand this? Everyone? Hello?
Yes.
Children, did you understand or not?
Yes, ma'am.